Let's start as review number 1 for Unit 6. This video is going to have number 6, 7, and 8, which all are dealing with angles and arcs. In number 6, you have an angle outside, the 42 degrees. You're solving for this arc x degrees, and you have the 58 degrees given that's in between these two secant lines. One of the formulas we looked at was dealing with vertical angles. When you have, these are both 42 degrees. The formula is that you're subtracting the two arcs that are between and putting them equal to the two vertical angles added together. What's confusing is most of the time this is x and not an actual number, but here we do have the number of degrees. So we're going to start with the big arc that's between the lines. Notice we're not dealing with this arc, we're not dealing with that arc. We just want the stuff in between. So we're starting with x, and we're subtracting the smaller arc that's in between, which is the 58 degrees. That gets put equal to our two vertical angles added together. Now, a lot of the problems you would have x plus x here, but here we have that measurement, so it's going to be 42 plus 42. Then it just becomes simple algebra 1. Add these, you get 84. You're going to add the 58 to both sides. And you're going to 142 degrees. Now, if you want to go back and check just to make sure you're correct, then you could do 142 minus 58 equals x plus x and see if you get 42, and that does work out. Number 7, now it's a similar idea. The difference is that on number 6, the angle is outside. Now in number 7, the angle's inside. So this 85 degrees is these two vertical angles inside. And what I kind of call this is I refer to this as the bow tie problem. So if I highlight the two chords, there's my two vertical angles. These two hold these two arcs. There's my bow tie pattern, which means I'm not using this arc, I'm not using this arc. Now when that happens, instead of subtracting the arcs that are held, we're going to add these two arcs. So we're adding 96 plus x, which remember is not 96x, equals, and just like on that previous problem, we had 42 plus 42, now we have 85 plus 85. There's our two vertical angles. 96 plus x, that equals 170, and then you're subtracting 96, and you're going to get 74 degrees for x. Number 8, we're given that ABCD, this quadrilateral, is inscribed in the circle below. Asks us to find the measure of angle D, angle C, and the measure of this major arc ADC. Now if we look at angle D first, there's angle D. One theorem is that when you have the quadrilateral inscribed, these opposite angles are going to be supplementary. A lot of times in parallelograms, we got used to the idea of opposite angles being equal. They were the same measure. No, that's not happening here. When it's in the circle, these two are going to be supplementary. So you'd have to take 180 and subtract 103 to get angle D, which is 77 degrees. Angle C is the same idea. It's just that you're subtracting 91 this time. There's angle C. It's across opposite from 91. Subtracting those, you're going to get 89. Sure. So angle C will be 89 degrees. So now we have on the inside, that's 103, 89. Now the part here, this is a little different. What is the measure of an arc, major arc ADC? And I say major arc because I know with 3 letters, it should be more than half the circle. Now, like last time, I'm going to highlight arc ADC. I'm going to start at A, going along the arc through D, and I hit C over there. So there's the arc I have to find the measure of. So I'm looking for how many degrees are on this arc. Now notice that when I started at A, and I ended at C, which lead me to this angle. So this inscribed angle is going out to and intercepting this arc. When that happens, this angle is going to be half of the arc. In other words, I have to take this angle and double it to get this bigger arc. 103 times 2, 206 degrees. There's arc ADC.